Welcome back to God Maths. I hope you enjoyed our previous lessons. Today we will look at sequence and series, and remember to subscribe to this channel for more lessons. A sequence is a set of numbers that follow a given order, and a series is a sum of a given sequence. Now there are so many sequences of numbers. For example, we can have even numbers which start from 2 and follow up as follows. We can also have odd numbers. This set of numbers can be continued because it is following a certain pattern, and it is the same for the set of odd numbers. There are so many other types of sequences and series, but in our lesson we are going to look at the two basic types, which are the linear sequence, also called arithmetic progression, and the exponential sequence, which is also called the geometric progression. We will look at the linear sequence first. Given the set of numbers 4, 8, 12, 16, and so on, and another set of numbers it will be identified that in the first set of numbers, the next three terms will be 20, 24, 28, and that follows. Then in the second set, the next three numbers will be 11, 13, and 15, and it continues. Now these terms can easily be identified because when you look at the previous terms, there is a common difference between them. And so we use that common difference to obtain the next terms that follow. Now any sequence that has a common difference between consecutive terms is what we call a linear sequence or an arithmetic progression. Now in any linear sequence, the first element is called the first term and is conventionally represented by A. And a common difference between them is also represented by D. So we have first term of a linear sequence as A, and a common difference is represented by D. Then the general term, which we also call the nth term of AP, representing arithmetic progression, is given by A, which is the first term, plus n minus 1 times the common difference, where n is the number of the term. So n represents the number of the term, so that the ninth term will be equal to A plus 9 minus 1. That is 9, so n is 9 times D. Let's take a critical example. Now if we are given a sequence, an arithmetic progression 5, 8, 11, 14, and so on, and we are asked to find the 10th term of this sequence, then we will say that from the nth term of an arithmetic progression, the 10th term is equal to A plus 10 minus 1 D, where we know that A is the first term of the sequence and D is the difference between consecutive terms. So here our A is equal to 5, and then D is equal to, we can pick any two consecutive terms and subtract. So let's use 11 minus 8, which is equal to 3. Then our 10th term is equal to 5 plus 9 times 3, which is 10 minus 1 is 9. And this will give us 5 plus 27, which is 32. Note that we also represent the nth term of an AP by UN. So the 10th term is called U10. And we will take further examples on this. Find the 11th term of the given AP. And we know that the nth term of an AP, UN, is A plus n minus 1D. So for the 11th term, which we call U11, that will be A plus 11 minus 1D. From the question, our first term, A, is equal to 2. And then our common difference, the difference between two consecutive terms, is 4. So our U11 will be equal to 2 plus 11 minus 1 is 10 times 4. And this will give us 42. Then for the next question, we are given some information. We are given that the first term, A, is equal to 19. And the common difference is negative 5. So if we are finding the second term, which is U2, then that will be equal to A plus 2 minus 1D. A is already given, plus 2 minus 1 is 1 times negative 5. And this will give us 14. That is the second term of this sequence. Then the next question, we are finding the 12th term, which we call U12. And that is equal to A plus 12 minus 1 times D. A is already given in the question, plus 12 minus 1 is 11. And that is 19 minus 55, which will give us negative 36. And then the last one, the nth term. The nth term, that is the general term of an AP, which is given as UN equal to A plus n minus 1D. We have A as 19, and then D is negative 5. So 19 minus 5n plus 5. 19 plus 5 is 24 minus 5n. This is the nth term, so the final answer will contain the variable n. We will take another example on this. Find the linear sequence whose 8th term is 38 and 22nd term is 108. We have learned that UN is A plus n minus 1D. And so U8, which is the 8th term, is A plus 8 minus 1D. That will give us A plus 7D. We are told that the 8th term is 38. So that is an equation. Then U22 is also A plus 21D. That is 22 minus 1. And that is also equal to 108. That is our second equation. Now we need to solve these two equations simultaneously to get the values of A and then D. So solving simultaneously, you can refer to our lesson on simultaneous equations. You have equation 2 minus equation 1. And that will give us A minus A as 0. 21D minus this will give us 14D. That's equal to this minus that is 70. So we divide through by 14, and then D is equal to 5. Then we will put D equal to 5 into any of our equations. Let's put in equation 1, and we will have A plus 7 times 5 is equal to 38. So A is equal to 38 minus 35, which will give us 3. in finding the sequence, we know that the AP is, the first term is 3, then the second term will be 3 plus the common difference, which is 8. Then the third term will also be 8 plus the common difference, which is 13, 18, and so on. This is the linear sequence. Next, we will look at the sum of the terms of a linear sequence. The sum of the first n terms of any given arithmetic progression. Sum of the first n terms, which we represent by Sn, is given by so we are going to basically look at how to apply this formula. And so given an AP or a linear sequence 11, 13, 15, 17, and so on, we want to find the sum of the first 12 terms. And in finding that, we already know that Sn, which is the sum of the first n terms, is given by n 2a plus n minus 1d all over 2. And so the first 12 terms, which we will call S12, will be equal to, n is now represented by 12. So 12 in brackets 2a plus 12 minus 1d all over 2, which will give us 2 goes into 12, and that is 6. Then we already know that A represents our first term and D represents our common difference. So A is equal to 11, then D is equal to the difference between consecutive terms, which will give us 2. So our S12 is going to be 6, then in bracket 2A plus 12 minus 1 is 11D. And that will give us 6. In brackets, we will have 22 plus 22, which will give us 6 times 44. So that will give us 6 times 44, which will give us 6, 4 is 24, remainder 2, 6, 4 is 24, 26. So that is the sum of the first 12 terms of this sequence. We'll take another example on this and then take our assignments. Find the sum of the first 6 terms of the given sequence. And we know that the sum of the first n terms is given by all over 2. And so S6, which is the sum of the first 6 terms, n is now 6. 6 minus 1d all over 2. Then from this, A is equal to 5, the first term. Then D is equal to 3 minus 5, which will give us negative 2. And so S6 is going to be 6. In brackets, we have 2 times 5 plus 5 negative 2 all over 2. 2 goes into 6 to give us 3. Then in brackets, we will have 10 minus 10. 10 minus 10 is 0. So we will have 3 times 0, which is equal to 0. So the sum of the first 6 terms of this sequence is 0. Now, try the second question on your own. The 20th term is called U20. The sum of the first 20 terms is called S20. So solve this on your own and the answers will be provided in our next lesson. In our next lesson, we will look at geometric progression, which is also called exponential sequence. See you then.